Question 14. Write each equation in its equivalent exponential form and solve for the variable. So we have a logarithmic forms here. So we want to write in exponential form equivalently. Remember, base in the log is base in the exponential form. And the log value is the exponent of the base. So 16 is a value. So that means x raised by 4 equals to 16. So we solve for this. We fourth root of both sides. And because it's an even index, and we have positive, negative 2 values. So we get x equals to, right? So the exponent and the index are the same. So rational exponent is 4 over 4, which is x raised by 1. And the 16 is 2 raised by 4. So we get a positive 2, negative 2 values, right? So it's the same to say negative 2 raised by 4, that's a 16. And positive 2 raised by 4, that's 16. So fourth root of 16 is either positive 2 or negative 2. We have two solutions. Let's say B. Base in log is 8. So it's still base in exponential form. And the 2, which is the value of the log, is the exponent. So equals to the value, which is x. So 8 squared is 64. So x equals to 64. Now let's see C. Base is 5, exponent is 3, value is x. So 5 times 5, 25 times another 5, 125. So one solution. And here we have 3, base raised by negative 2 equals to x. That's x equals to 1 over 3 squared, which is 1/9. Right, so we write the logarithmic form in its equivalent exponential form, and we solved for the variables. We see sometimes we have 2 solutions, sometimes we have 1 solution. Let's see 15. 15, we want to do the opposite way. So we have exponential forms here, and we want to write in log form. So base in exponent form is the base in log form. So log base 3, the value is 27, that equals to the exponent, where exponent is also 3. Well, we can write this way. Okay, we can start from the exponent because log form is exponent. So 5 equals to log base 2 of 32. C 2 equals to log base 10. Remember, log base 10 is by default. We don't really have to write 10 here. And 100. So 2 equals log, regular log or common log of 100. So by default, the base is 10. And this one, so negative 3 exponent equals to log base 4 of 1 over 64. And that's it. Let's say 16. We want to evaluate. So evaluate, so this one we can write as log base 3 of 81. 81 is 3 raised by 4th power. Remember, we have a property. When the value has exponent, we can put the exponent in front of the log. So that becomes 4 log base 3 of 3. Well, when the base and the value are the same, that equals to 1. So 4 times 1 is 4. Okay, Well, another way of solving this is this. So log base 3 of 81. We see, okay, we don't know what this is. Let's see, it equals to some x. Then we can rewrite as exponential form. So 3 raised by x equals to 81. And 81 can be written as 3 raised by 4. So base 3 the same on both sides of the equation. So that means the exponent have to be the same. So x equals to 4. Okay, so we could solve this way, or we could use the log property to solve it. So in this case, we see in the value, so 7 raised by 8. So this exponent can be pulled up front. That equals 8 log base 7 of 7. Again, when the value and the base are the same, that equals 1. Let's see why. If we have log base a of 8, let's see this equals to x. Then we write it in exponential form. That's a raised by x equals to 8. Well, this a is 1, right? So x equals to 1. So that's why log base a of a equals 1. So when the base and the value are the same, equals 1. So log base 7 of 7 equals 1. 1 times 8, that's 8. Well, let's see this one. This one we can write as log base 5, or 1 over square root of 5 is square root of 5 raised by -1. Okay. Then this -1 we can pull up front. That equals -1 log 5 of square root of 5. Then square root of 5 also we can write it as 5 raised by half. Then this half being put up front of the log. So -half log base 5 of 5. Again, the base and the value are the same. It equals to 1. So get -half. Well, let's see D. Remember the meaning of ln. ln equals to log base E. Right? So this is shorthand. So ln is a shorthand of log base E. So that means this is ln E of 4. This 4 go up front, right? So I have 4 times ln E. Well, ln E is a log base E. ln E is a log base E of E. Again, the value and the base are the same, so that equals 1. So 4 times 1 is just 4. Okay. Okay, let's finish. Yeah, let's finish 17 also. Because 17 is also about log, but it's about log function. Okay, we want to graph the log function, identify domain and range. So log 3 of x, let's graph here. Log base 3 of x. Let's pick some values. Let's see x and log base 3 of x. Remember the domain of this is x greater than 0. Okay, x has to be a positive number. So let's pick 1. Log base 3 of 1. So 3 raised by 0 is 1. So that means equal to 0, right? So log any base of 1 equals 0, because a to the 0 power equals to 1. Okay, as long as the value is 1, doesn't matter the base, it's 0. So now let's pick 3. Log base 3 of 3, that's 1, right? So at least 2 points. So 2 points, so 1 comma 0. Let's see, this is 1. 1 comma 0 have this point. Then 1, 2, 3. Let's see, this is 1. So 3 comma 1. So we know the graph of log like this, smooth, right? Because the domain has to be a positive number, so it only goes on the right-hand side of the y-axis, and this side goes like this, past those 2 points. So this is log base 3 of x. So identity, no, I mean the domain is x greater than 0. X has real positive number. We can write in interval notation is 0 up to infinity. What about range? Range, we see the all real numbers. So negative infinity up to or past infinity. Because this keeps going, takes all negative y values. And this side keeps going, takes all up positive y values. And log base 4, right? Log base 4 is very similar to this, right? We will have, if we change this one to be 4, so if 1 still get a comma 0, then we change 3 to be 1, right? So it's only 2 points. We still have 1 comma 0, but we won't have 3 comma 1. We have a 4 comma 1. So the graph, let me use black color to graph. We have, so this is 4, before was 3 comma 1. Now base is 4, we have 4 comma 1. So still goes through this point. So the graph is a little bit lower than this, than the other one. So this red one is log base 4 of x is b. Okay. Now let's see this one. Log base 2 of x minus 2. Let's make a table here. So let's see x, then we have log base 2 of x minus 2. All right, so let's pick 3. Because if it's a 3 minus 2 is 1. Log base 2 of 1 gets 0. Then let's pick a 4. Because log base of 4 minus 2 is 2. Log base of 2 of 2, we get 1. Okay. So if I use green color to graph this, a graph here, same here. I have 3 comma 0. So I have this point, 3 comma 0. Then I have 4 comma 1. I have this point. So my graph goes like this. And because you see x minus 2, so at x equal to 2 is my vertical asymptotes. For A and B, for those two graphs, you see y-axis is a vertical asymptotes. But for log 2 of x minus 2, 2x equals to 2 is a vertical asymptotes. Why? Because x minus 2 has to be greater than 0, which means x has to be greater than 2. So all the values, little bit big, as long as it's bigger than 2, is in the domain. So we graph like this. Okay. So this is function of log base 2 of x minus 2. So it's very important to draw this dotted line, the vertical asymptotes, which is x equal to 2. Now let's see this one. Let's use another color. Let's use the purple color. So let's see the domain first. So domain is x plus 3 greater than 0. That means x greater than negative 3. Right? Base is 3. So let's make a table here first. Let's see x log base 3 of x plus 3. Okay. So first, let's pick x to be negative 2. Right? Because if x is negative 2 plus 3 is 1. Log base 3 of 1 is 0. And then let's pick 0. X is 0, x is 0, 0 is 3. Log base 3 of 3 is 1. So we have these 2 points. Negative 2 comma 0, negative 2. So that's negative 1, negative 2. Negative 2 comma 0 at this point. Right? And what's our asymptotes? Let's draw our asymptote first. So x equals negative 3 is our vertical asymptotes. So let's draw that first. So the domain is x greater than -3 or -3 up to infinity. But range is the same. Range is all real numbers. So we have -2, 0 at this point. Then we have 0, 1. So 0 is here. 0, 1 is here. So our graph looks like this. All right. So this is a graph of log base 3 of x plus 3. All right.